So I research cockroaches. My name's Evains Francois. I just graduated from Poly, and I will be attending Northwestern in the fall. Well, I've always liked animals, and what attracts me to mechanical engineering is kind of like the smaller things. Like like seeing how things work. So that like the gears and like the building things, that really attracts me too. And so I looked at which labs in Johns Hopkins studied biomimicry, and so the one that I found just happened to study cockroaches. So we looked at insects and reptiles to see how we can incorporate how they move about into small robots, with the idea that we want to make these small autonomous robots move in like clutter terrain as efficiently as possible. So we look at animals that can move in clutter terrain because they had like millions of years of adapting and like polishing off their techniques and adaptations. So many examples of it, like generally like planes and birds, but then like even more specific like Velcro, because like those seeds, they're called burrs that like stick onto your clothes and like fur and things like that. And then like it's become even more and more deep as in like medicine. They study mosquito like noses, their needles, to see how like they can make like needles. So I looked at cockroaches. I had a couple projects, but my main one was looking at their antenna. Antenna are like one of the most common ways of insect navigation, and so I wanted to see like whether or not it's feasible to incorporate antenna into robots. First, I just looked at how the antenna worked, so I had to study the anatomy of cockroach antenna, and the second part was to come up with my actual experiment. If we're going to incorporate antenna into robots, we need to see what will happen if the antenna malfunctions or something goes wrong. So my project was to compare cockroaches with 2 antenna, 1 antenna, and no antenna, and see how they navigate differently when placed in a little arena. So I would set these cockroaches in the arena, and there would be a whole bunch of pillars everywhere. And every time an antenna touched the pillar, I would record which direction it went, how it touched the pillar, different things. So I recorded 7 different aspects of the collision, and then from there I had a big spreadsheet of all the different attributes of each collision. And then from there I was able to break down and look at the data in different ways to see any trends that I might find. And the idea behind that is like if we do incorporate antenna into robots, if an antenna breaks off or like malfunctions, we need to know how to change its like navigating behavior to still navigate with 1 antenna to the best of its ability. I really do think that high schoolers should do research because in my class we had I think 16 other students doing research, and I think that us 16 students learned so much. And so I was like, out of my friends, there was like 2 of us that did research out of my like group of friends, and I could tell the 2 of us like we got skills from research that the other ones didn't. Like I learned how to send professional emails. I learned how to like kind of be a professional kind of when I was young. So I think it was a really good experience to have, how to present at lab meetings, how to ask like adults questions, because when I first got to lab I felt really weird about asking adults questions, especially in my lab, because I didn't want to be like annoying, like an annoying high schooler. But you know, I realized that those in my lab, they just want to help. So when I ask them questions, it's not like, oh my gosh, go away. It's like, oh, let me help you out. So it was a really good experience learning those things. Getting them earlier, I feel like will benefit me in college. I get a head start above the other students. So I think it's really important that everyone gets the opportunity to get those skills.